Okay, thank you for the opportunity to talk here this afternoon. I think I'm standing in between you and lunch, so I'll be brief. So this is the topic of the talk here is supporting the transition to solar PV energy supply team and our role in transitioning to a low-carbon economy. Can I see the screen here by any chance, or it's not on the monitor? Okay. So this is a brief outline of my talk. We're just going to introduce kind of what solar PV is doing globally and domestically, what we're doing here at the CSIR, just right down the hill from where we're sitting, some of the services that we can offer you and maybe some of your clients around pre-feasibility studies for solar PV plants, systems on their facilities, and what we're doing in terms of the quality and reliability of solar PV plants just on the other side of the hill in Building 46. Okay, so many of you are aware, I'm sure, about the growth in the solar PV sector globally, 100 or so gigawatts per year in the globe going up, and that forecast is bright and expected to continue to grow. Here in South Africa, we have already about 1.5 gigawatts of solar PV connected and operational, and with the expected growth up to, say, 8 or 10 gigawatts by 2030, according to the ESCOM draft IRP. So there's going to be growth here in solar PV, we expect, and there will continue to be growth globally. And so we want to play a role in that to help ensure a successful transition. This is an image of some of the output that we get from our own PV power plants here at the CSIR. We've had our first plant, the ones you see on the N4 particularly, right? The single-axis track plant, that's 558 kilowatts of tracked PV. Right next door is 203 kilowatts of dual-axis tracked PV. And then we put up a rooftop system on Building 17, and now we're in the process of commissioning another 5. Thank you so much. We're in the process of commissioning another 5 rooftops, which will bring us to a total of about 2 megawatts of solar behind the meter here at the CSIR. So it's pretty exciting for us. We're practicing what we preach, if you will. And what this graph shows is some decline in our consumption from Swanee in the blue bars. Our rise in the solar PV contributions is the red trend line, and the colors are some different PV plants. So what you don't see here right now is the additional 911 kilowatts of rooftop that are currently being commissioned. So we're moving in the right direction there to transition the CSIR Pretoria campus from carbon-based to non-carbon-based electricity. So in summary, kind of what we're doing here to support the transition, I think, we're building our own PV plants at the CSIR. We're doing quite a bit around human capital development. We have a number of students who come through from the various universities to learn more about solar PV and operations and maintenance and testing and certification and modeling. We're doing pre-feasibility studies for industry and state-owned enterprises who are ready to take the step and take a look at this. What does this next step in the journey mean for us? And we're also developing infrastructure here to really focus on PV module quality and reliability testing. We want to make sure that when this transition happens, as it's happening, and we fast forward 5 or 10 years from now, we actually have functional, efficient solar PV plants online. We don't want these things to be failing early, degrading more than promised, and so on. So our focus is really about getting it right now so that we can reap the benefits over the 25-year lifetime of a plant. So in the end, it's really reducing the risk of deploying PV. So on the pre-feasibility space, what we can do for clients is really just to kind of introduce the idea of solar PV and maybe what it can do at a high level for their operations. So site visits, location assessments, how much land do you have, how much rooftop do you have, does it make sense to put PV here, are you really ready for that? What are some of the potential pitfalls you can find? The soiling loss there is an interesting one in the top right corner. I was a bit shocked when I came here in 2017 in the middle of wintertime and just saw really dirty solar PV panels. And it turned out that our single-axis tracker plant had gotten basically 20% loss. It was performing 20% lower than it should have been if the modules were clean. So dry season soiling is a real issue for, the output of a solar plant. So how do you manage that? First of all, manage that expectation and then put in the proper O&M to handle it. But it's a real thing here. Bottom left-hand corner, kind of insulation, right? So the fuel for a solar PV system, of course, is the sun. This fusion reactor, 96 million miles away, sending us tiny little photons and converting them into electricity. It's really kind of amazing, right? But that only works when the sun is shining, and then, of course, when clouds come and storms come. So there's some variability in the resource. So we have to understand that. What kind of resource can you expect? How much fuel can you expect in the wintertime versus summertime? And how does that line up with your load? What is it that you're trying to power with this renewable energy? So there's some uncertainty there. So that's the bottom center graph. You can look at P50, P90 kind of analyses and say, what would I expect? And would I expect this power plant to produce, 90% of the time, 50% of the time, 10% of the time, and size and plan accordingly. And ultimately, you take all this uncertainty and you put it into, this is what we expect your plant to produce for you, each month of the year for the next 25 years. And how does that fit with your appetite, your budget, and your needs? We can also help with the business case analysis. We have some calculators of our own that we've developed in spreadsheets. There's other software you can use to do it. But the idea is to try and think about this investment in terms of what's the levelized cost of energy. If that's a new term for you, that's simply like what you would expect to pay for electricity over the lifetime of the plant. So there's the CapEx and the OpEx, but you're going to produce energy from that system over 25 years. When you do the economics and look at net present values and so on, you get down to a levelized cost of energy. And as the graph shows on the right, we've shown here at the CSIR, based on real data from IPP contracts based on the REAP program, in 2015, people were willing to build these plants and sell power to the distributors at 62 rent cents kilowatt hour, which is pretty incredible. You may have seen there's other reports that come out in the news occasionally internationally, the competitiveness of this business in places that have high resource and good climate is really quite incredible. I think some of the best numbers I've seen come out of Argentina. It's a high, dry, cool climate, so the solar PV, that's perfect for solar PV. We've got pretty decent temperate climates. We've got a good solar resource. We should also be in that sort of competitive space. And one of the interesting things from my point of view, one of the projects I worked on before I left the States was helping Facebook locate a data center in New Mexico, which is where I'm from. Facebook and other companies like them, they want a 100% renewable energy portfolio across their global fleet. And so they're looking for places where they can get the cheapest, most reliable, renewable energy. And New Mexico happens to be a place like that, very similar actually to South Africa in terms of climate. We're also at about 1,500 meters. We have a lot of clear, sunny days and a lot of cool days as well. And so based on that and a number of other factors, Facebook decided to build their plant number 8 with 30 megawatts of distributed solar. It was a cooperation with the state and the local utility. We have our PNM, our Public Service of New Mexico, which is a lot like an ESCOM. They came in and they said, well, if you do 10 megawatts over here and 10 megawatts over there and 10 megawatts over there, and we do some accounting, we will basically sell you electricity at such and such a price. Facebook gets the tax credits and cheap electricity, and PNM and New Mexico benefit from it doubled or quadrupled the amount of PV solar we had on the New Mexico grid in one shot. And the cool thing was nobody had to pay for it except for Facebook. Anyway, that was a huge digression. I apologize for that. The bottom slide here is sort of matching generation and demand profiles. That's another important thing to consider when you want to do solar PV. So the value really of this part of our offering is to provide a basis for a go, no-go kind of decision. You have a client, they want to consider this. We can put some numbers down together pretty quickly and say, does it make sense to pursue? It'll also provide the client a basis from which to evaluate bids, right? So if the decision is to move forward, the tenders are issued, bids come back, and bidders are going to have different value propositions, price points, mixes, technologies. What does that all mean? So it's a means to provide the client some education and some further understanding about how these things operate. It's not a blueprint on how to build a PV plant. That's what the commercial sector is supposed to do, right? So we're just here to help the potential owner of the plant make the right decision when the time comes. So the second part of what we're doing, so that's the planning part. The second part of what we're doing is really trying to improve the quality and reliability of the plants. So we don't want to be 5 years into this and your client comes back and says, hey, why isn't this PV plant doing what you said it was going to do? So how do we avoid that risk? There's a number of ways to do it. First is to kind of understand what the risks are. And I kind of grouped them into 4 areas here. And I think one thing that I see quite a bit, not just here, but everywhere, and the numbers are being published in journal articles, plants are underproducing on average by, say, 3% globally, I think is about what we see. So why is that? Well, honest mistakes happen. Those can be disastrous. We want to avoid the honest mistakes. We can have weather file inaccuracies. So again, your weather file is your fuel, right? So you want to have your predicted fuel resource well understood. If you overpromise the amount of fuel going into the plant, it's going to underdeliver. Overselling to win a bid, I think that's a real problem, right? So it's, you're competing with 5 other companies, and so maybe you want to just say you can get a little bit more out of this plant than you know you really can. So it's a real issue. Module degradation and quality in manufacturing, that's where we're going to focus. We think that's a real risk, and certainly globally that's a potential risk. In general, solar PV panels are built well. They're made to last 25, 30 years. But you can occasionally get a bad batch or a bad, what we call bill of materials. The specific components from the specific manufacturers that come together to make a panel to operate over 25 years don't always work right. So we're there to kind of help screen that out. System degradation, operations and maintenance, a big deal, right? These plants, one of the nice things about solar PV plants is they're scalable and deployable. You build them quick and you can build them anywhere. So in a matter of months, you can have megawatts of solar PV online. But they have to operate for 25 years. So we don't want to underestimate the role of operations and maintenance in the overall output and the overall LCOE of this asset. And then finally, you have environmental disasters and grid availability, which I think is maybe more of a problem here in South Africa than I experienced in New Mexico. But when the grid is down, so is your solar PV, right? At least for large scale without battery backup. So that's going to impact your bottom line as well. So that has to be understood. We're going to focus on the quality and reliability of the components. Just like you think about when you buy clothes, phones, shoes, cars, houses, or whatever, quality matters, right? Quality is like, what is this thing doing for me now? How does it look? How does it feel? Is it built right? Does it have the material, maybe the brand that you want? That's quality now. Same thing goes with the PV panel. You want a good quality panel. Unfortunately, most of us in this room don't have the experience with solar PV panels, right? We can pick up an iPhone, we can pick up a Huawei and go, this one's kind of cool, right? Solar PV panels, maybe they're a little bit more mysterious for most of us. So we have some idea what that quality should look like, and then more importantly, what's that quality going to do over time? And that's what I consider reliability, right? So we have some new infrastructure with the help of TLIU and the CSIR and the Energy Center. We've come together with the funds and the resources to build up some environmental chambers to do accelerated stress testing. And a sun simulator in the middle there, which is our sunshine in a box. So for about 45 milliseconds, we can simulate the sunshine and measure performance of modules over a broad range of temperature and irradiance. So really nice equipment designed to help us assess the quality and reliability of solar PV panels. The chambers are designed to stress modules from 85 degrees Celsius to minus 40 degrees Celsius over multiple cycles. And so a standard module certification would do that 200 times. For a reliability program, we'll do that 600 times. So the idea is you're simulating in an accelerated fashion the thermal stresses that happen on this solar PV panel because of temperature changes that they would normally see when they're sitting on your rooftop in the middle of the day versus in the middle of the night. Those temperature stresses can have a negative impact on all of the bonds, all the solder bonds and the different layers and the different material components within the module. So we want to try and accelerate that and look for failures that we typically would see in the field if a module's not built well. So there's other legs of the program. There's also on the right-hand side, you can see a mechanical load tester. We have that device there to apply mechanical stresses on the panels to simulate wind loads, snow loads, transportation, people walking across the panels to do maintenance, those kinds of things. You've probably seen pictures like that, and you're like, is that really good for the panel? If you've seen the Solar World company at trade shows, or used to anyway, they would have a guy on a mountain bike, bouncing around on a bunch of solar panels set up to look like so you have to look underneath. So there's electroluminescence imaging that we can do, which is like an X-ray for a solar panel. Just like you can't see if your bone is cracked, the X-ray can. We have similar instruments as well. So a lot of great kit. We're bringing it online now. We're kicking off a pilot program as we speak. We have 4 module bombs, bill of materials, in this first phase. South African branded, 2 Chinese branded, 1 Indian branded manufacturer. Modules that are available in here is South Africa. We'll run them through this test program, which is this, we're following the CSA ANSI standard C450, which is really the latest in open source reliability testing for PV modules globally. So really, the CSR is Energy Center, and the solar PV team is really here to help reduce the risk on your next solar PV project, okay? This is the test sequence that we'll be going through the modules. There's several legs there that, for example, the TC600, that's that thermal cycle that I mentioned, 85 to minus 40 over 600 cycles. The DH2000, for example, that's damp heat. So we do 85% relative humidity at 85C for 2,000 hours. And then in between, there's a humidity freeze. So there's really a lot of good science that's gone into developing these standards and these sequences over the past 50 years. And it's really an international community that has come together to put this standard together. So we're benefiting from that, and we're going to implement that here, and then hopefully convince PV plant developers, owners, financiers, insurers that this is value added if you want to ensure the quality and reliability of your PV plant for the 25 years that it needs to operate. So in conclusion, in summary, continued growth in PV sector is expected globally and in South Africa. Pre-feasibility studies are a great way to sort of get into the business with your clients and see if they're interested at a high level. And then certainly if and when it does come down to building the plant, we're here to help with the de-risking of at least the module quality and reliability portion. So with that, thank you very much for the opportunity.